dear students, welcome to Nuclear Physics lecture. I'm Dr. Parvez Ahmed. In this lecture, we will talk about the neutrons. We will try our best to answer the question of what is a neutrons. Uh, just like according to Jeffrey Green, the neutron is complicated enough to be interesting, but is simple enough to be understandable. This has been the saying by Jeffrey Green when he was being asked about the neutron. So, what is the neutrons? Let's start our discussions from the atoms. You know what is atoms? Atoms means initially, in the 18th century and in the beginning of 19th century, atom was considered to be the fundamental particle of the matter until the people discovered about the nucleus and the nucleons. So atom was being found to consist of atomic nucleus and electrons revolving around the nucleus and different orbits. Uh, Inside the atomic nucleus, you know that we have neutrons and protons. So protons by itself, they are not the fundamental particles and being found to made up different car. That is, proton consists of two up cars and one down cars. And these cars, just like we mentioned in the previous lectures, they are being bonded together by the gluons in the form of a neutron, so in the form of the proton. Similarly, neutrons is being made of three cars, that is one up cars and two down cars. And these cores, they are being bonded together by the gluon. We have strong interactions that we call the nuclear strong nuclear force. So what is car? Cars are being the fundamental particles. There are different cars. That is, we have up cars, and up cars had a span plus 2 by 3 that we mentioned in the previous lectures. And a down cars means again another fundamental particle, the proton and the neutron, with the span minus 1 by 3. And there's been an interaction inside the span. We have strengths. This is some sort of the discussions. Which the scientists said is tells. Have no ending at all. What is a neutrons? So again, let's start our discussions. Neutrons is one of the nucleus that is found inside the nucleus, and it's being made from one up cars and two down cars. So up car has a charge 2 by 3, that the charge 2 by 3 times the charge of the electron, and a down car and the down car has the charge which is equal to minus 1 by 3 times the charge of the electron. So what's the total charge the total charge of the neutron, that we can say that the net charge. By the net charge, we have to add up the charge of all these cores. So when we add up the charges of all these cars, so it's equal to 0. So that's why we're saying that a neutron has a net charge equal to 0. That is, charges are there in the form of the cars, but when they add up, so the net charge they have if equal to 0. So that's why we're saying that neutrons, they are being a neutral particle with a net charge equal to 0. So when we saying the net charge equal to 0, so it's because of these because of the fact that we add up the charges of these quarks. So when we add up them, so it's equal to 0. Otherwise, there are being charges inside the neutrons, but their add up effect, their total effects is equal to 0. That is, we have to add up. That is neutrons. So here you can see that the up card has a charge equal to positive 2 by 3 times the charge of the electrons. The down card, it has a charge minus 1 by 3 times the charge of the electrons. So what is the mass? You know that the mass of the neutron is almost equal to the mass of the protons, which is 1838.68 times the mass of the electrons. That is, we say that the mass of the neutron is equal to 1.6749 in 10 raised to power minus 27 kg. So if you convert that into in unit of the energy, so neutron has a mass equal to 939.5656 mega electron volt per c square, which equal to 1.008667 u. Uh, so let's have some formal discussions about the neutron. That is, the neutrons. The neutron is a subatomic particles with no net electric charge. This is a formal definition of the neutrons. And another most important fact when we discuss neutron with respect to the nucleus, that is the central part of the atoms. So with respect to the nucleus, it's being said that neutrons are usually bound via strong nuclear force and atomic nuclei. And you know that it's also obvious that nuclei, that is the central core of the atoms, consist of the protons and the neutrons. And both of them, they are being collectively called as nucleon. That is, proton plus neutrons, they are collectively known as nucleons, and they constitute the majority portion of the nucleus. Um, the number of protons, you know that as we already mentioned, that the nucleus contains neutrons and protons. So inside the nucleus, both the neutrons and the protons, they have their respective roles, they have their respective identity. So the number of the protons inside the nucleus determines the elements, and or we can say that it recognizes the element, or it is the identity of the elements. And the number of neutrons determines the isotopes. I mean, it's the identity of the isotope, that how many isotopes a particular elements have. For example, we are saying that nitrogen 15s and nitrogen 14s have 7 protons and 8 neutrons, 8 neutrons and 7 neutrons respectively. That is, we can say that different isotopes of nitrogens have the same number of the protons but different number of the neutrons. So it's basically verify the fact that the number of the neutron basically determine the different isotopes of the same element, while the number of the proton is basically the recognitions at the identity of a particular element. And stability of free neutrons and mass. So another important fact about the neutron, and it's that neutrons, free neutrons are unstable. Uh, that is, they undergo beta decay with the lifetimes equal to 885.7 plus minus 0.8 second. I mean, this is the lifetime of the free neutron. That we say that free neutrons, there's been unstable. After that, it undergoes beta decay. So what happens? When we are saying that free neutron is unstable, so what it mean when we say that the free neutron are unstable? It means that they cannot be stored for a longer time. That is, after this particular duration, that we have the lifetime equal to 885.7 plus minus 0.8 seconds. So after this time, we cannot store it in a free form. So what happened? Uh, we're saying that beta decay occur after this duration of time. So after when neutron decay, or when neutron goes through beta decay, so what actually happens, a neutron is converted into protons plus electrons and neutrino. I mean, this is the basic equations for a neutron decay. That is, we have a neutron. So when the beta decay occur from the neutron, so it's been converted into protons plus electron plus electrons neutrino. Uh, if you look at the mass of the neutron, so it is slightly larger than that of the proton. That is, the mass of the proton, the mass of the neutron is slightly larger than that of the proton. Uh, Neutrons do have a spin that we denoted by a small s, and it's the quantum number. That is, neutrons are spin half. That neutron has the spin half. That is, s is equal to 1 by 2. And it is a very important identity for the neutron. Just because of this half spins, we say that neutrons are called as the fermions. And this has been the identity, this has been the characteristic due to it has the interactions inside the nucleus. Uh, Due to this spins, it has angular momentum, and the angular momentum is basically given by S, capital S, equal to h card under root S into S plus 1. So particle with the angular momentums have a magnetic moment that we denoted by mu, and is given by mu is equal to g small g q divided by 2m and 2s. G is for g factor, q for the charge, 2 for the mass, and s for the angular momentum. So s, I mean span that tend to make the angular momentums, uh, because of which the particles or the neutron has a magnetic moments. So what it mean? It mean that neutron has a spin that we already discussed. It has a half spin, and that spin is responsible for the angular momentum, which is in turn responsible for the magnetic moment. So that's why we're saying that though the neutron do not have an electric charge, but it has a spin. So just because of that spin, it has angular momentum and it has magnetic moment. So how do the neutron have a spin? So in order to understand the concept of the spin for the neutron, we have to look upon the spin of the electron. So just like you can see it here in the figure, that is orbital and spin, that is we have the spin of the electrons, which is orbital and spin, that is equal to 1 by 2. So angular momentum gave rise to moments and magnetism. I mean, electron do have the spins and has angular momentum. So just because of this, the spins and angular momentum, it gave rise to magnetism. So just like that, neutrons and electrons moment can interact. So uh, neutrons, uh, neutrons are sensitive to magnetic moments and the solid. I mean, what we mean by this particular slide, we mean that just like the electron has the spin and angular momentum, so just because of this, the electron has the magnetic properties. I mean, it produces magnetism. So by the same analogy, by the same concept, we said that the electron has a spin and angular momentum. So just because of that, the neutron that interacts with the other particle, that is it can interact with the electrons or interact with the other particles. So that's why we're saying that in this particular sentence that neutron and electron movements can interact, which mean that neutrons are sensitive to magnetic moments and solid. So this is the only property as a result of which neutrons interacts with the matter, and just because of this, the neutrons, they are being controlled. I mean, their activities, they are being controlled, and their ways being modified. So that's all we have for the neutron. See you in another lectures with a new topic related with the neutrons. Till then, bye bye.